For this video, we're going to start looking at the first fundamental theorem of calculus analytically. And just to start with, if you have some function, and I'm using the derivative because you can see I'm going to take the antiderivative, but if you have some function that you're integrating from a to b, you'll take the antiderivative and you'll have f of b minus f of a. The antiderivative of evaluated at the upper limit of integration minus the lower limit of integration. So it's sometimes called the total change or net change theorem, but one other way to write it would actually be to add an f of a to each side. So f of a plus the integral from a to b of f prime of x dx equals f of b. And it just depends on what you're trying to do. I like this form if I'm ever given as one point and I'm asked to find another. So this, you can imagine, is a start. And this is your start amount or start time, start whatever it is, starting position. And then this represents, this piece right here is your net change, which would equal, if you add those together, start plus net change will give you your final. So this is one way to look at it. One way is just to say, hey, here's our net change, and the integral represents that net change, but this is a little bit more useful to me. So what we're going to do is actually integrate some functions, and we're going to do definite integrals. So for this first one, we're going to say f prime of x equals x squared minus 3, and it's on the interval from 1 to 2. So what we're going to do is integrate this. We're going to find the integral of f prime of x on this interval and actually write down what it represents. So I am integrating x squared minus 3 with respect to x from x equals 1 to 2. And to do that, I'm going to take the antiderivative, so this will be x cubed divided by 3, or 1/3, minus a 3x to the first divided by 1. And I am integrating from 1 to 2, and you can see the notation here. And then you'll see that it's f of b minus f of a. I've done the antiderivative. Now I'm going to take my upper limit of integration and plug it in, and then take my lower limit of integration and plug it in, then I'll subtract the two values. So you might wonder, why when I took the antiderivative, why didn't I put a plus c? So I'll actually put the plus c here for this problem, and then I'll show you what happens to it. So this would be a 1/3 times 2 cubed minus 3 times 2, say plus whatever our c value is, minus 1/3 times my 1 cubed minus 3 times 1 plus c. And if you take a look, I have a positive c, then I'm subtracting a c, so they would cancel out. So for definite integrals, you do not need a plus c. So to work this out, 2 cubed is 8, so this is 8/3 minus 6, then this will be minus 1/3, then plus 3. So I have 8/3 minus 1/3 is 7/3, and negative 6 plus 3 is minus 3. So this is 7/3 minus 9/3, and I have that this actually equals a negative 2/3. So you might wonder what that actually tells me. Well, if you think about it graphically, I have the graph of y equals x squared minus 3. So its vertex is 3 below the origin. It's a parabola pointing up. Well, I'm integrating from 1 to 2. So from x equals 1 to wherever 2 falls, but I have a negative value, which should make sense because I'm going to have more graph that's negative than positive. So more of it's below than is above. This is actually also represents, you'll see up here, we're starting with an f prime and then we're getting an f out of this. It's the net change in f. So the net change in the height of f was negative 2/3 from x equals 1 to x equals 2. And that's one way to look at it. So it really is a net change in height of the graph of the actual function, not of my derivative, but of the actual function, which in this case would have been 1/3 x cubed minus 3x plus some number that we don't know what is. And nor did I need it because it would just cancel out and subtract. So that's our first example. We're going to do this again. So I start with f prime of x equals 3 times the square root of x, and I'm on the interval from 1 to 4. So what I want to do is figure out what in the world does this represent and what does it equal. So I'm integrating f prime of x from x equals 1 to x equals 4. So to do that, I'm actually going to start by rewriting this. This is the integral from 1 to 4 of 3x to the 1/2 dx. And this is a scalar. This 3 can actually come outside, or you can leave it alone, but we're just taking the antiderivative first. So that'll be x to the 3/2, 2/3, bring this 3 down, and then I don't need a plus c, but I'm going from 1 to 4. The 3's will cancel out, so this will be 2, and then my x is being cubed with the square root from 1 to 4. So then what I would do is actually take my upper limit of integration and plug in. So this is 2 times the square root of 4 cubed minus 2 times the square root of 1 cubed. Now it's a square root, so I can actually pull 1/4 out. So this will be 2 times 4. I have 3 4's inside. Pulling 1 out leaves me with 1 inside, the square root of 4. Well, that's 2 times 4, and then the square root of 4 is just 2, minus the square root of 1 cubed is just 1, so minus 2. 2 times 4 is 8, times 2 is 16, minus 2 equals 14. So what does this represent? This represents the net change in height of the graph of f of x from x equals 1 to x equals 4. Again, it's in the change of height of f, not f prime, but the change in height of f. It also represents the area underneath 3 square root of x from x equals 1 to 4. So there's a relationship there. One more example here, just a little bit of trig. What if your f prime of x equals secant squared x? And we're talking about the interval from 0 to pi over 4. Well, if I'm going to integrate my f prime of x from 0 to pi over 4 with respect to x, I'm going to first take the antiderivative, and I know that the antiderivative of secant squared x is tangent x because the derivative of tangent x is secant squared. I'm going from 0 to pi over 4. Again, I'm going to take my upper limit of integration and plug in first, so it's tangent of pi over 4 minus tangent of 0. Now I know that tangent is the slope of the radius on my unit circle, so if I draw a quick unit circle right here, pi over 4, 1/4 of the way to pi, the slope of that radius is 1. Remember, tangent is sine over cosine y over x. It's the slope. Minus, here's my 0. The slope of this radius is just 0. So 1 minus 0 equals 1. So this integral is 1. That's finding it analytically. What does it represent? It represents the change in the height of my function f of x, which is tangent x plus some value from x equals 0 to pi over 4. Or you could say it's the area underneath the secant squared of x graph from x equals 0 to pi over 4. So it's both things there.